All right, here is lesson 112. It's called Graphing and Solving Systems of Linear and Quadratic Equations. Remember, linear equations have an x usually. Quadratic equations have an x squared. All right, just as a review, if we have a system of equations, we have two or more equations. We've just seen linear systems so far, and the solution to these systems is the point where the graphs intersect. So if we have y equals 14 minus 4x, and we have y equals x plus 4, if we graphed those, the solution is where they intersect at the point 2, 6. All right, systems of equations can also consist of a linear equation and a quadratic equation. So here are some examples. System A, we're going to use y equals x squared and y equals x plus 6. How many solutions are on this graph? Well, there are two, because the linear graph intersects the parabola twice. All right, system B, we're going to look at y equals x squared again, but we're going to change our linear equation to y equals 2x minus 1. This one has one solution because it only intersects the parabola once. And we could also have something like system C. Again, we're looking at y equals x squared and then y equals 3x minus 5. This one has no solution because the graphs do not intersect. So if you look right here at the graph, see how they don't intersect at all right there? So there's no solution there. All right, example 1, solve by graphing. So A, we're going to look at y equals x squared and y equals 9. So the red parabola is y equals x squared. So I'm going to graph y equals 9 in green. So here is y equals 9. And how many solutions do I have? I have 2, right? One of them is at 2, 9. And the other is at negative 2, 9. All right, what if we look at this one, y equals x squared, which again is the red line, or the red parabola, and y equals 2x. Well, if we want to graph 2x, our intercept is 0, and our slope is 2. So up 2 over 1, up 2 over 1, right? I could go down 2 over 1 as well. So that's a terribly not straight line, but go with me there. So this one also has two solutions. It intersects at the origin, 0, 0, and it also intersects right here at 2, 4. So that's how you solve those, by graphing. All right, you could use a graphing calculator or Desmos to solve as well. So I just, again, plugged these into Desmos. And how many solutions does this one have? It has 2. One is right here at 0, negative 2. And one is right, oh, that's not 0, negative 2. At 0, negative 3, excuse me. And the other one is here at 1, negative 2. All right, here's another one. How many solutions does this have? This one has no solution because they never intersect. All right, we can also solve these, using substitution. We haven't done this in a while, so quick review. They're both y equals right now, so I can set them equal to each other. So I can have x squared plus 3x plus 3 equals negative x plus 1. I'm going to combine like terms, so I'm going to add x to both sides. So I get x squared plus 4x plus 3 equals 1. Oops, not there. Subtract 1 from both sides, so I get x squared plus 4x plus 2 equals 0. All right, do you know how to solve quadratics? Yeah, we've been doing this all the time lately, right? So you can use the quadratic formula, you can factor. Let's try to factor here and see what happens. X squared is x times x. How do you make 2? 2 and 1. Let's see if that works. X squared plus x plus 2x plus 2. That didn't work. All right, so actually this one doesn't factor. If we look here, when we combine like terms, we only get 3x instead of the 4x that we need. So we're going to have to do the quadratic formula for this one. Remember, quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative b would be negative 4 plus or minus the square root of b squared. So 4 squared is 16 minus 4 times a is 1 times c is 2 all over 2a. 2 times 1 is 2. So we get negative 4 plus or minus the square root of 16 minus 4 times 1 times 2 is 8 over 2. So we get negative 4 plus or minus the square root of 8 over 2. So that's super ugly. The answer key was wrong. So let me show you what the graph looks like real quick. I graphed it on Desmos. And it looks like this. So I think I can delete it in a minute. Here's our answers in decimal form. And that's gross. No one wants to do that without a graphing calculator. So the book did a terrible job on that one. Sorry about that. All right, let's look at this next one that should work better. So for A, if they gave that to you, you could totally leave this for your answer, or use your graphing calculator or Desmos. All right, let's look at B. This one works out better. Y equals x squared plus 2, and y equals 4x minus 1. So again, we're going to substitute, set them equal to each other. So x squared plus 2 equals 4x minus 1. Subtract 4x from both sides. So I get x squared minus 4x plus 2 equals negative 1. Add 1 to both sides. X squared minus 4x plus 3 equals 0. All right, this one can be factored. So x squared is x times x. 3 is 3 and 1. We need a positive 3 but a negative 4x. So these are both going to be negatives, right? So let's double check to make sure this works. X squared minus x minus 3x. I'm just foiling here. Think back to that. Minus 3x plus 3. So combine like terms. X squared minus 4x plus 3. Yep, that works. Okay, so now we have to get our solutions. So x minus 3 is equal to 0, our first parenthesis here, and x minus 1 equals 0, our second parenthesis here. If we solve, we get x equals 3 and x equals 1. All right, so now what do we do with those? All right, plug them in to our equation. So let's go up here. Y equals 4 times x, when x is 3 minus 1. So 12 minus 1 is 11. So one of our solutions here is 3, 11. And the other one, y equals 4 times 1 minus 1, is 4 minus 1, which is 3. So our other solution is 1, 3. All right, we can plug those in to make sure they work, or I also graphed it in Desmos. Let me make it tiny so we can hopefully see here. I should have erased something first, huh? All right, here is our solution at 1, 3, and our other one at 3, 11. All right, if you would like extra practice, please check out the lesson practice on pages 765 and 766. Let me know if you have any questions. Talk to you later.